All right, we're back at Jay-Z and Beyonce's recording studio project that they're working on here. They plan to put in an AC and a furnace in this bad boy to make sure everything stays temperate. That's always good for the instruments and whatnot, to make sure they're not getting all crazy with changing humidity and whatnot. All right, so they plan to have exposed beams and a vaulted ceiling, so it's all going to be open, right? All open, all up in here, right? Give a nice cool look to that. So how many cubic feet do they need to account for when they're picking out their furnace and their AC? The dimensions are labeled down there. We got 20 feet by 25 feet by 9 feet. And just like the last time we did that problem with this structure, the roof is going to be a 12-12 pitch. Okay, so to me this sounds like a volume problem since we're trying to figure out how many cubic feet, how much air is going to be in there, right? And, approximations are just fine here. We're picking out an AC and a furnace, so we're going to have to choose accordingly based on the volume. All right, so let's do it. Let's find out our volume. Well, I am going to break this thing into two parts, okay? So what I'm going to think about here is, let's see here. I'm going to break it down with the rectangular prism that we're going to see here, right? That's this guy here. That's going to be like my rectangular prism, and of course that would go, straight back as well. But we can think of it as like a rectangular prism with a triangular prism on top. So this guy, that's my triangular prism. Oop, lost the line there. There we go. Okay, so I got a triangular prism. Two parts. All right, I think the first one's pretty easy. The area of the big base, so 20 times 25. That's going to be 500. And my volume of that rectangular prism is going to be the area of the big base, 500, times my height, which is 9. That equals 4,500. Okay. So let's see here. This is the area of the big base, right? Alrighty. Because I'll end up using this number again. That's what's nice about it. So let's jot this down. Volume of the rectangular prism equals 4,500 feet cubed. And then we also want to find out our volume of the triangular prism, the roof part of this, right? Because it's going to be all open. So let's do that now. Let's do that in blue. So I need to figure out the area of my base. Well, my base is this triangular part, okay? So we're actually not going to be using that big B from over here. I'm not going to be using that again, actually. I thought about it, but I guess not. Okay, so let's find the area of that triangle. Well, I know the area of the base is 20, so big B for the triangular part. That's 20. Times my height. Well, what's my height? What is this? I think I remember. Okay, so if that whole thing is 20, then this is 10, and since it's a 12-12 pitch, the rise and run are the same, so that height is also 10. So times 10 over 2, that's the area of my base, so it's 100 feet squared, all right? If I plug in my calculator, if I notice 20 divided by 2 is 10, times 10 is 100. That's the area of my big base of this triangle. Well, what's my height of, like, when I'm thinking about in the respect of the volume? That's this dimension right here. So I'm going to take, my volume is going to be the big base, 100, times the height, which is 25 in this case. So it changes up based on the way you're looking at it. And that's totally fine. All right. So that would end up being 2,500 feet cubed, right? Feet cubed. So I've got my two volumes here, and I need to add these together. Let's see if I can make this a little smaller, give myself some room. Whoop. There we go. Well, just going to add them together, right? 4,500 plus 2,500. Keep changing colors because it's fun. 7,000 feet cubed. Nice. So when they're picking this out, they need to make sure that their furnace and their AC units, right, those two things, They need to be able to handle at least 7,000 cubic feet of space. So obviously you want to go over, if anything, to make sure that it cools properly, but that's what they need to worry about. A lot of those units are also just dealt with in square footage, but it also helps to think about it in volume, because ceiling height, open ceilings, those can all change the standard volume. Like a lot of times they're basing that off of just say like an 8-foot ceiling or a 9-foot ceiling. But here we're dealing with a little bit more space because of that vaulted ceiling. So volume formulas are important here. Okay. Alrighty, ladies and gentlemen, Drake has decided to get into the farming business in Huntley, Illinois. And right now, business is booming. So much so that he has to invest in more grain bins. Alright, one could say that Drake maybe started from the bottom. There he is right down there at the bottom. And now, he's here. You see what I did there, kids? You see what I did, little Drake up top? Ooh, we'll keep him there because that's fun. Alright, so let's see here. How much grain can he hold in this bad boy if it's 30 feet in diameter? The sidewall is 20 feet and the overall height is 35. I'm going to start labeling some stuff. Okay, so what we have down here is a circular base. Oops. That was terrible. Much better. Alright, and I know the radius is really the important part when I'm dealing with a volume problem, right? So my radius, if the diameter is 30, my radius is 15. And I'm going to hold off on writing units just because it gets a little bit crammed in these things. Okay, the sidewall is 20 feet, so that means this guy's 20. It says the overall height is 35, which would mean that's 35. So my height of this top part, which looks to me like a cone, is 15. And I know my radius will be the same as the one down there. Alright. Now obviously it looks a little bit funky, you know, not necessarily to scale right now. The angle of the picture looks a little weird. So we'll go with it though. We got our numbers down that we need. So how much grain is this thing going to fit if we can fill it all the way to the brim? I don't know if you actually fill these things to the brim, but I'm just going to say we do. Alrighty, let's do this. Looks like a two-part problem, don't you think? Okay, well, let's start with the cylinder. The cylinder part of that grain bin. What was my formula for my cylinder? Oh yeah, it's just volume is big B times my height. Well, what's my area of the base, the big B? Well, it's pi r squared. Pi times 15 squared, and then my height is 20. Lovely. So 15 squared is 225 times 20. That gives me 4,500 pi. Remember that little technique with leaving the pi out of our calculator and then we can just toss in it at the end. And that would be feet cubed, right? So that's the volume of the cylindrical part. Now we're talking about the cone up top. And it's a similar formula, area of the base times my height, but we divide it by 3. So let's plug some numbers in. The area of my base is going to be the same as the area of the base of the cylinder, right, because it's sitting on top. So that's the pi times 15 squared times my height, which in this case is 15, not 20. And all of that gets divided by 3. I'm going to plug these guys into my calculator without the pi, so 15 squared times 15 divided by 3. That gives me, let's see here, let me get a little more space. There we go, got a little more space. So my volume is 1,125 pi feet cubed. Okay, so that's the conical part, the cone up top. Alright, well, why don't I add these two together, don't you think? So if I take 1125 pi plus 4,500 pi, I'm going to get total volume to equal 5,625 pi feet cubed. I think an approximation might be best. You know, although Drake's heavy in the farming business, he likes decimals. Okay, so he doesn't like it in terms of pi so much. So 1,700 sorry, 17,671.5, and that's going to still be feet. I'm running out of space. Cubed. Okay, there is my approximate one. Sound good? Alrighty. Well, now Drake knows how much grain this bad boy can hold, and he can decide how many he's going to buy from there. America.